Hi, Srivalli. Hi, Srivalli.
Hi, Shanti.
So first, let us understand the comparison between among AI, generative AI, and machine learning. This
Yeah.
is a very good document. One person shared on LinkedIn. I am using that. Uh, First, the column is artificial intelligence. Second column is generative AI and machine learning. But what I am taking is artificial intelligence. I am taking first and second machine learning, then third one generative AI. But because the sequence is like that, it is grown in the industry. Machine learning came from artificial intelligence. Now let us see overview of each model. So if you take artificial intelligence, refers to the simulation of human intelligence in machines that are programmed to think and learn like humans. Now let us say uh, we all know from childhood we learned a lot of things. By year on year, we keep learning even now also. Whatever age is there till our last breath on the earth, right? So those all
Mm.
are knowledge. Actually, our brain is catching up and storing in the subconscious or conscious mind. The same kind of activities, if you want to feed to mission, make that expertise in that. Yes, it is possible through artificial intelligence. So how it is, human intelligence need to be fed to the machines. So they need to learn it, like what we learned historically, incrementally from childhood to till this age. The same way we need to feed that information and train them and make them as a model. Model is nothing but particular activity. It is expertised. Now let us say you take any kind of topic, um, marketing. Okay, so
Mhm.
marketing, there are a lot of things need to be done. Okay, the expert is there, domain expert. Three, four experts, they wrote some kind content and they trained with a lot of statistical data, the model. Okay, the artificial intelligence model. It means what happens after that. It simulates the similar things. Now, if you take a statistics, in statistics there is advanced topic called probability.
Yeah.
Even in probability, there are different topics, subtopics. Okay, but in high level, I am talking. Probability is nothing but because this happened with the past data, past history, it is going to happen. You take electioneering in any country, in India or US or anywhere. What they do, they have taken the sentiments of the people, they have taken the past results in that constituency, they have taken how many people voted and what kind of people they are, what kind of parties they are supporting indirectly or directly. They all consolidated and fed to the machine learning. After feeding into the
Mhm.
machine learning, the model is trained it is going to give the analytics, and they're going on keeping feeding the information day by day from the market analysis. So when it is made, feeding it, they're training them continuously. It is evolving to get upgrade. So that kind of
Oh.
mindset we are also developing by hearing the news, by watching TV, such kind of thing, reading the newspapers. So, because we're
Oh.
gaining the knowledge. The same way we need to use in the artificial intelligence to train any kind of models. Then architecture is broad set of techniques and algorithms. See, let us say if you want to process particular data, we need to use some kind of algorithms. Those algorithms are developed incrementally historically. Those need
Mhm.
to be inbuilt, and through that algorithms, the data is going to be analyzed. It and training
Yeah.
data, diverse, encompassing various fields and applications. Obviously, the topic what I took, electioneering. Electioneering needs that kind of data collection from each constituency across country to analyze it and take the people sentiments and consider what is happening in social area also. All those things they are going to consider and data, and they are feeding to the algorithms, right? That is all about artificial intelligence. It means it works like a human brain only for that activity, for that field or application.
Mhm.
Okay. Now, what is machine learning? Overview of machine learning is a subset of AI that involves training algorithms to learn from and make predictions or decisions based on data. I discussed about the electioneering in this topic in artificial intelligence. You take the same field. In that field, you might have collected data from different constituencies. There are categories of the constituencies in Indian election. One is state election, another one is central election. Okay,
Mhm.
parliament election and assembly election. You take one segment here for assembly election. Then what I'm going to do, I'm going to divide the application of the data under
Mhm.
electioneering only, and I'm applying for machine learning algorithms. Those algorithms I'm using and running the data to do the prediction analysis. This is called through the machine learning. It means there is a mission, it is learning from the data and it is taking the decisions and giving the predictions incrementally.
Mhm.
Even if you see before elections, 1 week or 2 weeks before, day by day, the rating used to change from different analyzers, okay,
Mhm.
predictors basically, because each individual's data collection style is different, facts
Yeah.
collection. Some people might have not collected correct facts. So those facts, the machine learning analyzed and gave it to them. But it is not the real facts. It is fake facts. It can be fake facts also. It can be cooked up facts also. It can be fabricated information also. So many ways they polluted the data also. With those analyzers, it failed the predictions. But one
Mhm.
analyzer, exactly, he did it. He has been working in this electioneering since two, three elections of parliament and assembly. So his predictions were exactly matched it. Why means he
Mhm.
has taken the real data, actual analysis he has done it. It means he took from different places the data, analyzed it, and all the algorithms he applied it. So now, what is the architecture in machine learning? Various models, including supervised, unsupervised, and reinforcement learning. It means supervised is what data we are feeding, what result it is giving the algorithm, then is it real or not? That is the supervised. Unsupervised is sometimes when you train the machine, your algorithms are working, you need to confirm it, and after confirmation, you can go under unsupervised to get the dashboards in seconds or minutes. Now you take ChatGPT or Merlin or any kind of Gemini tools. They all are
Mhm.
well-trained LLMs. They became popular because of their implementations were successful across fields, right?
Mhm.
Once upon, if you see, Google search was popular before these ChatGPT came into OpenAI came into picture, because it was giving correct search options, correct content it used to bring. If I ask about one item, it is supposed to bring the same item. It is not. It was not bringing other items also. Not like that. If you take 15 years back, the Google search was different. The algorithm was
Mhm.
different. Now, if you see recently, it is very powerful and you will get the exact information. But 10 years back, it was different. 15 years back, it was different. Different. It means incrementally they have modified the algorithms and trained their learning modules to learn from our test what we are typing in search options and picking up the same thing, analyzing within their past trained models and bringing the data under unsupervised activity, because they have supervised earlier how this model is going to work, how it can be implemented, right? And reinforcement learning. Reinforcement is learning is what this model need to be trained it. When you trained it, the model need to be activated with algorithms to get latest information. Now, if you see
Mhm.
chart, if you have worked on particular profile making or particular translator activity solutions, you take one session, prompt session. In that session, you might have written multiple prompts. Now you ask ChatGPT, can you recollect my prompts and print them? Yes,
Mhm.
it is going to print it because it remembers. It recollects all the information and lists the prompts, AI prompts, what you wrote in that session, particular for particular activities, right? The same way, training data is what labeled data sets for supervised learning, unlabeled for unsupervised learning. Now, if you see, LLMs were tested very well. across globe on the internet, and they tested for different domains, different areas also how Google search works. It brings more content and in a presentable format, in a consolidation way, what we are looking for. That kind of algorithms were built and they tested under supervised learning how this model is working. Then that is called labeled data sets. Labeled data sets means those are trained, well equipped, well tested. Now, unlabeled are there are different ways we are going to ask, not in the same way, not in the same model, but it is
Mhm.
converted into that model. It is going to give the information according to our requirement also. Okay, they have given the approach how you are supposed to work. They train them under supervised learning. That's where they are working here under unsupervised learning. Do you think OpenAI
Mhm.
people are monitoring all our prompts, each of us? There are millions of people working on ChatGPT
Mhm.
daily
Yeah.
across globe. They don't supervise them. They have trained that
Mhm.
LLMs and released them for public, right? So this is about
Right.
machine learning. It means machine learning is a further extension within the
Yeah.
AI, work with different algorithms. Those algorithms can be converted into ML models. Those models are being used it. Right? Now,
Mhm.
how this is converted into generative AI? First, let us see overview of generative AI. Generative AI focuses on creating new content or data that is similar to what it has been trained on. It means you take this machine learning itself, whatever we are doing, electioneering, now, if you want to convert that into generative AI service, you have already trained model in ML setup, either Azure or
Mhm.
AWS cloud setup. Now it is very easy to convert into generative AI because these all algorithms all are built in into the generative AI. How it is? Generative AI focuses on creating new content or data that is
Mhm.
similar to what it has been trained on. Yes. Then it means it creates the data also. Earlier we used to supply the data manually, but that is not required. It works internally. Okay, then architecture is typically uses generative adversarial networks, GANs. We studied this one in 1 month back or some few weeks back. GANs, generative adversarial networks, or variational autoencoders, VAs. So this is the architecture. It works. Okay, it means GAN is nothing but generative adversarial networks. So and variational autoencoders. Basically, what happens? This is going to work for internal algorithms, ready-made algorithms. It builds it. It brings the data after working internally with with the GANs and VAs. It is operated the generative AIs basically. Training data is specific to the types of content to be generated. Now, let us
Mhm.
say you have a tool, Mocarano is there, right?
Mm.
Test data generation.
For
If you give the
mock
columns and
data.
rows, yeah,
Mm.
mock
Yeah.
data, it creates the data. It looks like original data only, right? Including
Yeah.
phone numbers, it brings it. It means it is a
It gave
fake
the
data,
original
but
data.
still
Yeah.
it is a fake data. It is not the real data. It creates it randomly by taking some
Mhm.
samples. The same way, it is specific to the type of content to be generated. It means you take any kind of service, generative AI service, it works
Mhm.
internally, it brings the results to us, like machine learning models. We don't need to worry about its architecture because these all are included in the GANs and VAs, this supervised learning, unsupervised learning. Because for each activity, it is a new one for that. New training happens, new supervised learning happens like in the ML, but those all are hidden here. They all are automated within the generative AI design itself. Then training data also, it takes care of internally this training data. It means you don't need to bother about these two things. Then algorithms, you don't need to bother what algorithms we are using. Let us say in machine learning, if you see, we used to work a lot. The data scientists, ML engineers, fiddle with R programming, NumPy, then there are so many TensorFlow, such kind of tools, right? So we don't need those tools. Those might have been built in this, but we don't know what is internal mechanism. We use a translator. the translate is going to work for that. We use
Mhm.
test analytics, yes, it is going to work for that. We use scanner, yes, it is going to work for that. It brings the data into the code format, JSON or XML format. That's the output it is going to give it. So these are the differences. It means artificial intelligence, it takes the human brain activities, human knowledge on particular field, particular area, and it converts into algorithms. Those algorithms are going to work on the data. Then it is going to give the feed, whatever we ask the questions according to that. Then the ML, how it works, ML is going to work on particular algorithms, on particular field activities. Then it is going to train the model. It is going to develop the model, machine learning model. Within that machine learning model, under supervised category, it is going to give the results. Then once you are satisfied with that results, you are going to convert it into unsupervised model. Let us say you are creating a chatbot. What is the purpose of chatbot? You have some kind of questions and answers. You prepared already some data and it is there in the database. So you are going to attach the chatbot to listen to those things and digest it and work according to that. You trained that, you tested it under supervised learning. Now you are installing that chatbot on your website for particular activity, or let us say patient activity. Now it is going to ask some set of questions first. So after that, it is going to get answers. After that, it is going to analyze with the existing data. If these kind of symptoms are there, what is the disease symptoms? What is going to happen in future? What immediate action they need to take? What are the store medicines it need to recommend? All those things are there in the database. So it is going to pull under unlabeled, unsupervised learning. It is going to give that. So it means the chatbot activities here, it is automated through supervised learning, but we don't need to do all those things here. Supervised learning, all these things. We are going to save a lot of time with generative AIs, with the GANs and VAs are going to take care of that, and it is going to train internally. It is going to give the result immediately, right? So this is the overview of each model. Now, what are
Yeah.
the key features? If you see, now key features are first for A. Let us see, ability to
Mhm.
simulate human reasoning. What is reasoning basically? With different combinations, we should think. Our brain should think. If you go to any
Mhm.
competitive exams, they're going to give some kind of multiple choices or some kind of passages and ask answers to give it, such kind of things. It means whether we are able to understand the content, whether we are able to understand the policies, procedures, and against to that, what decisions we can make it, our brain functioning, it is going to be tested in the reasoning. Am I right?
Yeah.
So the same way, the key feature is for reasoning, it can be used. It means examination point of view, very well they can use artificial intelligence questions.
Mhm.
Integration across diverse applications. Yes, obviously you can integrate the data with different applications and consolidated information can be pulled it.
Yeah.
Continuous learning and adaptation. Yes, obviously it keeps on learning whatever data we feed it to the artificial intelligence mission or the instance, a instance, I can say. Okay, the instance can be converted in the form of robot, in the form of chatbot, in the form of any kind of activity. Okay,
Yeah.
so next one, if you see the machine learning part, what it is there in the key feature, predictive modeling and analytics. What is predictive modeling? If you take electioneering, yes, they
Yeah.
did all predictive modeling, predictive analytics they used to do every day. What happens in election? Okay, what are the analytics it gives? Those analytics they are going to discuss in different channels, and they make all kind of this one, right? So it means already they have fed the data, they simulated human reasoning also into the AI, that is transformed into machine learning activity under predictive modeling and analytics activity. Okay, ability to handle large volumes of data, yes, obviously, then improves accuracy and efficiency over time. Yes, if you use all these things perfectly, if you have collected the perfect analytics data, perfect data
Mhm.
on
Yeah.
different feeds, yes, it is going to work and give the accuracy, right? Model.
Mhm. Mhm.
Then let us say, Generative AI. Now, in ML predictive modeling, you have seen how it is automated in generative AI is creation of new and unique content. Yes, unique content means for that function basically can generate high quality, realistic outputs. Yes, obviously, the quality of outputs to bring it, it is automated internally. Why it is automated through these processes? Okay, then creative and artistic applications. Yes, it gives multiple ways the presentation of the data. Okay, so that is the beauty of generative AI. Okay, it means here a lot of efforts are saved here. Just you are giving
Mm-hmm.
those things on the basis of it can generate some other data also, and it can take samples and it can analyze and it can give the quality of the output. Okay, realistic outputs. Okay,
Yeah.
when you supply the correct data, it gives the realistic data, right? So that is the
Mm-hmm.
purpose of the generative AI, right?
Mm-hmm.
Now, performance comparison. Accuracy wise, artificial intelligence depends on specific applications and algorithms used. If your algorithm is not correct, entire process is going to collapse up to machine learning. It is going to fail
Yeah.
basically. The result is not correct. It means basically
Mm-hmm.
the algorithms first what they are using, they need to be cautious, they need to be expertise. That's where they used to give more preference, more salaries to data scientist guys, because the data scientist guys they know the domain expertise, particular business domain expertise. Okay, so all those with expertise, they are going to create the algorithms, and those algorithms they are going to execute it. These algorithms are also they were designed through particular tools, statistical tools like R programming, TensorFlow, including Python also. Okay, so
Mm-hmm.
speed is generally fast, but varies with complexity. If you are giving more data, complex analysis, it is going to be slower, obviously. That is common. Then
Mm-hmm.
versatility is high versatile, applicable across various domains. Yes, various domains it can be applied it. How is machine learning implemented in performance comparison wise? It has got accuracy high when trained with sufficient and relevant data. It means it need to have relevant data. If it doesn't have relevant data, obviously it is going to slow the process, right? The speed is
Mm.
fast for trained models, but training can be time consuming because initially it needs analysis, a lot of analysis by building
Yeah.
those algorithms with the trained models. Okay,
Mm.
then versatility is broadly applicable across different fields requiring data analysis. Yes, one is electioneering you have seen. There can be some other
Yeah.
things also. Okay. Now let us say we have seen for 3 years COVID symptoms, COVID analysis, all these
Mm-hmm.
results, how it is, how deaths happened, it, what kind of predictions, precautions we took it. If you feed all these kind of things, in future, in next 50 years or 100 years, if this kind of viruses comes, what we are supposed to do, the predictions also can be given, what kind of precautions the governments need to be taken care, that also can be applied it with the past data. Is it neat? Is it correct?
Correct. Yeah.
Right? It is easy to
Mm-hmm.
predict it.
Mm-hmm. Yeah.
And when it can happen, that kind of viruses also, it can be predicted also. On what occasions it came in the previous symptoms, and when, how many days it was there, what kind of
Yeah.
symptoms it brought to the patients, all those can be fed by the doctors, right?
Yes.
Under
Yeah.
machine learning data, then it gives. So if you see that kind of analysis, machine learning models are very popular and very powerful also, right?
Mm-hmm.
Now, how
Yeah.
generative AI is going to work in this area? First thing is high in generating realistic content, assuming you have the reliable data, assuming you have
Mm-hmm.
complexity, and speed
Mm-hmm.
is varies with the complexity of the generation task. Basically,
Mm.
obviously, if more complexity is there, more probability need to be analyzed. It takes a little bit time, right?
Yeah.
So, versatility is primarily in creative and content generation domains. Okay, so basically the same way what we have taken here, content generation domains, it is going to be used for good performance. Okay, then use case examples. So, for artificial intelligence, if you see autonomous vehicles, you can use it. Use cases means live applying. where you can apply these AIs, basically artificial intelligence. It can be robots, it can be bots or something like that. Virtual assistant. Virtual assistants we have seen in many sites. There are chatbots. Bank sites, most of the bank sites have got chatbots. So they are
Okay.
virtual assistants. Okay. Autonomous vehicles are Google cars are there in India. You know that, right?
Yeah.
It drives self without having a driver. It drives. Okay. If you attach
In
that one.
India, I don't know.
No,
I
no.
think
In Bangalore, I have seen few years
I
back
see. I
itself.
see. Mm-hmm.
So the guy used to sit beside the driver's seat. The car used to
Mm-hmm.
go very slowly, but not with speed. Okay. Uh, then predictive maintenance. Yes, obviously predictive maintenance can be used. It you have seen that, right? We analyzed one missionary defects analysis with predictive maintenance model, right?
Yeah.
In machine learning, and we shown the solution how it can be converted into generative AI, right? That comes under
Yeah.
predictive maintenance, right? So by
Yeah.
taking the past defects, past defective items, how we are going to control that defects, how we are going to make quality of the deliverables to the market,
Mm-hmm.
right?
Mm-hmm.
This is all about use cases about artificial intelligence. Now, when it comes to the machine learning, specifically fraud detection is there, personalized recommendations are there, predictive analytics in finance. Okay, it need not be finance, it can be in any way. We have done for manufacturing industry, predictive maintenance,
Mm-hmm.
predictive analytics. But here he is showing as a finance. Okay, so
Mm-hmm.
fraud detection is basically if any fraud is happening, it is going to give alert, right? There are so many hackers. Their job is to hack the sites, hack the bank accounts, hack so many things, and destroy the things also. Okay, so that kind of frauds can be analyzed. It so
Mm-hmm.
personalized recommendations are, let us say we worked with personalized marketing also. What does it do? Like you have given past customers visits and their purchases also. Now new items have arrived to your circuit city or best buy. They can use this kind of thing, personalized recommendation system. Then they're going to feed the data. Now what we can when recommend to this customer means, it is going to say yes, in the past he has purchased this kind of items. Now you can recommend your existing items to order online, and now you can send it for campaign. Simple,
Yeah.
right? Then predictive analytics in finance, yes, obviously. Earlier, we our expenditure was that much, and in the past 10 years, we have seen a lot of calamities, natural calamities. Due to that, a lot of budget was incurred. Now, in next 10 years, what is the prediction?
Yeah.
It can be taken, right? Right, that is
Right.
all coming for budgeting purpose. So next one is choosing the right model for your needs. How you can do it best for broad applications needing intelligent automation and decision making. Basically, we need to use artificial intelligence for repetitive activities and also complex activities where human will take longer time to take a decision, and also human can occur with defects. To control those defects, we are going to use artificial intelligence, right? So it is not to replace the people, it is automation basically to simplify the task, to simplify the solutions outputs. Okay, use if you
Yeah.
need to simulate human like reasoning and behavior, yes, obviously. So sometimes human will have frustrations if they are working long hours. If they are in help desk, they'll shout at the customers also. Okay, if customer is asking some kind of stupid questions. Okay, but chatbot is not going to do that kind of frustrations, right? You ask 100 times, it is going to repeat in the loop only because it is programmed it, right?
Yeah.
So, example is developing a smart home system that can learn user preferences. Smart home system is, let us say, you have washing machine, you have security alarm, and you have health need to be pursued it for particular aged people. Then everything is automated under security system. Then if the patient is getting some kind of high BP, it is going to alarm it, then it is going to ring to the phone, what is the health care ambulance number 102 or 100 in the US. It dials to that
Uh,
number.
mm,
Okay, immediately ambulance will come. So that automated systems are there, smart home systems. Okay, then if washing machine is over, it is readily available, then it can siren. Yes, you can go and pick up the items. That kind of things. If new person is roaming around the house, then it can sense it. He is a new person. He never came to house. Yes, now we need to alarm it. Okay,
mhm,
this is one simple example he has given, but many complex applications are implemented in AI. Now let us see for machine learning. Best for data-driven decision making and predictive modeling, as we have discussed it. Use if you need to analyze and interpret large data sets. Yes, obviously. Building a recommendation engine for an e-commerce platform. Yes, obviously we discussed it. Recommendations for personalized marketing purpose. That is one of the e-commerce application activity for campaign purpose on the e-commerce systems, right? So
yeah.
this is about machine learning. Now, if you take it to generative AI, best for creative and content generation tasks. Yes, obviously, the personalized marketing needs the recommendation. The output is content, the recommendations it gives. Then use if you require generating new realistic content. Yes, that is also there. Creating digital art for media and entertainment. This is also another use case. Basically, you can use it.
Mhm,
But what we have been using on our generative AI, they are powerful. They are really live applications. If you take scanning the data, finance data from receipts, that is there. Then another thing, predictive analytics. Predictive analytics for manufacturing industry depends on the past defects. We are going to analyze it and we are going to control that kind of defects and taking the actions against different departments to change the process flows, right? We took that.
yeah.
Then another thing is third one is personalized marketing. Personalized marketing is nothing but this recommendations. We have automated it. So there are so many things. We are going to work on 10 different generative AI services. So they are more powerful than these descriptions, which we are going to see, right?
Yeah.
Any questions here? Any questions?
No.
Yeah, the examples what they have mentioned in this chart, these are the initial examples, but in our POCs, we have very live-based use cases, real business applications. We are using it.
Yeah.
Okay, right. So I'll stop this one.
Mm.